Greetings, the Astro 30 here, and I'm going to be talking about today a project that I'm commencing with now, a new one. It's another amplifier project, but with a little bit of a difference. Hopefully this one's going to work out a lot better than the last one sitting on the bench next to me here, but we'll start with this board first. This is a power supply board. Now, some of you may have already seen this around the place, but this comes from a person called Jim's Audio, and they actually have an eBay store which contain a lot more different kits than this, including valve preamplifiers, valve headphone amplifiers. They did have an input switching selector for stereo, but they're sold out of those. But this power supply, there's like about 3 more of these left, and I hope he's going to make some more because this is a really, really top quality board. It's 2mm thick, which is very strong. It doesn't even flex. So it takes 3 times 10,000 microfarad capacitors. The parts list says 80 volt. I've ordered some 50 volt ones. It also has a speaker protector built into the power supply using the popular micro PC 1237 IC, which has proven to be quite a good speaker protector. And it can run on a wide variety of voltages from 12012 AC up to 42042, I believe it is. It's not written on the back or anything, but it also features an LM317 and an LM337 positive negative adjustable voltage regulators to supply you with plus minus 15 volts, which is quite nice. So this whole power supply is all in one with a speaker protector built into it, so I don't have to have like 3 separate boards to do the same thing. And as I say, the quality of this board is very nice, and it's quite larger than I thought. It's marked 24 volt 30 amp for the relay here, which is just a standard Omron, which is one of these, which is, I'm kind of glad I kept it. Thing is, it's only a 5 amp contact relay, so I contacted the seller yesterday, and he said he found on Mouser a particular model which is the same as this, which is a G2R-2, which is what that relay is. And, well, as he said that would fit and work nicely in the board, this is what I'm going to use. And 5 amps should be okay for what I'm using it for. Now, bridge rectifier over here is a BP 1008, which I can't find any of. It's actually more of a JB 1008-BP. But I also spoke to the seller about that, and he gave me some ideas of certain types of this SIP package that would fit in here, because I did order some of these bridge rectifiers, which are KBU 808s, but, well, they're physically smaller, so I'd have to bend the leads, either all of the leads actually, to make it fit, and it's going to look rather weird. So I ordered another type of bridge rectifier from Australia, so that should be here in the next couple of days, which is similar to this and similar to what fits in there, but it's rated at 10 amp. This is only rated at 8. Not that it really matters, right? Well, it does, depending on the current that you're going to be supplying to the power amp. Okay, and Jim's Audio, the seller, is pretty good about supplying schematics and parts lists for it. Here's the AC input with the bridge rectifier here, the 3 filter capacitors, or the 2 sets of 3 filter capacitors, 10,000 microfarad at 80 volt each, with 2 100 nanofarads in there as well for high pass filtering. And there's 2 10k resistors between positive earth and negative respectively. And these are used to actually drain or bleed off the charge on these capacitors when the unit is off, because these large capacitances can hold a charge for days, literally days. And if you've turned it off and you're working on something and you come into contact with the high current VCC line and earth, you would know all about it. Especially if you shorted it, you definitely know all about it. Now, he calls this a high current, low current power supply. Well, I guess that's semi-accurate. Here's the voltage regulator section. It's just two adjustable regulators, one positive, one negative, and these resistor values are chosen to get around 15 volt plus minus at the output here. There's two FR104s in different directions. One allows positive to go through, one allows negative to go through. FR just means fast recovery. That's just a fast recovery diode. He's also going through a 100 ohm resistor before this. So these two diodes would be to isolate the regulators from the VCC line, and these 100 ohm resistors are there to drop the voltage going into the input of these regulators, because I believe the maximum input voltage is 40 volt. So, or 38, I can't remember the exact figure. Someone may want to put down in the comment section below what that actually is. But because this power supply is multi-power, in other words you can power it on anything from 12012 to 40040 I think it was. I'd have to check that. Yeah, at 40 volt DC you're putting close to 56 volts into the inputs of these regulators, and it's not going to last very long. So you'd have to put a dropper resistor in, and this also provides a 600 millivolt drop each side as well. So, but that's something to keep in mind when choosing your supply voltage, that what the actual voltage drop here is going to be, and then you may actually have to recalculate and change these resistors to change the drop to keep the regulators in the safe operating area. Down here is the speaker protector section with the micro PC1237. He's just drawn it as a square. I might redraw the schematic so it looks a little bit clearer, but it's okay for purposes of demonstration. Left and right inputs come in here through two 100k resistors which mix the signal together. Goes through a 100 microfarad capacitor here and a 56k impedance resistor. That takes out any false triggering from low transients such as deep bass, and yeah, it works the same as that other speaker protector that I built using the same IC, so I'm not going to go into it too much. The only thing worth mentioning though is with R26 it's marked R1K with 2 stars after it. It says R26 is dependent on the value of the VCC. So say your VCC was 36 volts, you calculate it by R26 equals plus VCC minus 12. I'll get to that in a minute. Divided by 0.03. Now that would be the current draw that the relay is drawing when it's engaged, theoretically. And so if it was 36 take 12, that's 24. So then you divide 24 by 0.03. Okay, so as I said, 36 for the supply voltage minus the relay voltage, which is what the 12 is for. And again, I'll get to that in a minute. Equals 24. We divide that by 0.03, which is the current, and we get around about 800 ohm. So you'd have to do a substitution there, which would make it 860 ohm. And it's also a 1 watt device. Now the thing about this 12 thing is, however, the relay is a 24 volt relay. That's the relay up here. If you were to run this on 12012, now it's only using the plus VCC line to power this chip. So that's at 36 volt, and then you put it through here. Yeah, it'll work fine for a 24 volt relay then. However, even if this was a direct short and you were running on 12 volts AC, so the VCC would then be 13 volts. Yeah, that's really, really low. So then we can then do our calculation with that he's provided would equal 1.6. We then divide that by the current draw. We'd need a resistor roughly at 56 ohm. Okay, but at that voltage you probably wouldn't bother. See, that's the thing that I'm curious about this 24 volt 30 amp relay here, because this IC, well, I don't think the IC really cares what the relay voltage is. That's dependent on VCC, but what I'm saying is the calculation up here makes it strange, because that really should be VCC minus 24 divided by 0.03 in my opinion. So working at 12.012, well, that relay is not going to work. So just also keep that in mind. It'd probably work fine with a 24 volt relay in operating at a VCC voltage of 35 volt. So we'll just keep in mind that the 24 volt relay will not work with 12.012 power supply unless it was a 12 volt relay. And if we were actually to do that calculation taking 24 instead of taking 12, which is what it should be in my opinion, so the VCC is now 35 volt. We take 24 off that, and then we yeah, that's 11, and then divide that by 0.03. We're now looking at a resistor value of about 320 ohm, which is the nearest value. So that's the power supply by Jim's Audio. It's a very quality circuit board, but I've got to work out the details here with the relay, but we'll do that in the video when I actually construct it. It's just a circuit board, that's all it comes with. There are no parts to assemble, it's not a kit, it's just a bare PCB. You've got to provide your own parts, which is what I'm waiting on. I'm waiting on a micro PC 1237, the filter caps, the other parts I can find elsewhere and buy them from JCar if I have to. And yeah, I'm also waiting on the FR104 diodes. You know, it is what it is. So the whole power supply is probably going to cost in total about $120 to build. I mean, the board itself cost about nearly $25. So that's the parts list. Just goes through all the variables that you need. It even marks what type of relay to use. It's a G2R2, which is what I've got, 24 volt DC or compatible, but it's not 24 volt at 30 amp. But anyway, and then I have to provide all these other parts myself, like the terminal blocks, the resistors, etc. So moving on to the next item that I've got. This is a 2.0 or stereo power amplifier kit, which I got in the mail yesterday, and I've already opened it. Now there's the two circuit boards. It's just two monolithic blocks that you've got to assemble. Now these boards are quite good quality, although the thickness is not quite as thick as that power amp. It's 1.5mm roughly, but again, it doesn't flex much. So this is another top quality board with nice through holes, and it's very compact. It's actually smaller than I thought, but it's using 2SB and 2SD output transistors for the output stage, and yeah, they'd most likely be Chinese knockoffs of Japanese transistors, and whether this is purported to run at 100 watt maximum on a power supply maximum of plus minus 45 volt. Yeah, I'd hate to see how long these devices will survive at that voltage. However, I'm not going to run it at that voltage. I'm going to be a little bit more conservative and run it at plus minus 35. And if you look at the back of the board, that's so cute. But over here is what the interesting factor is. It says power is DC minimum plus minus 12 maximum plus minus 45. So at plus minus 12 you'd probably get no more than about 10 watts out of it. So at 35 plus minus, I reckon I could push it to 48, 50 watts, but I'll measure that when it's complete. So those are the power amplifier boards and of course the bag of parts, and it has two heat sinks which you mount for the drivers and the VBE multiplier respectively. So that'll be an upcoming video of assembling this and testing it. However, this brings me to my next point. I went out and bought one of these heat sinks. Now you buy two of these, lock them together, and you can actually put a fan on it to blow air through it, and this is what's called a fan assist heatsink. Well, I'm not going to be using it for that. I'm going to be using it as just a heatsink, and both circuit boards will sit nicely evenly spaced out on the heatsink. Unfortunately, it's 83, I think, or 84, the max, millimeters high. I plan to use a 2-unit rack mount case to put all this in. And the internal cabinet height of a rack mount case at 2 unit, well, the one from JCar anyway, is 83.1. So this is about 0.9 millimeters too big. And I'm going to have an awful difficult time mounting the heatsink, mainly because this goes horizontally instead of vertically for the fins. Mounting this to the internal piece, mounting rails inside the case that allow you to separate things from the top and bottom. They have mounting rails, and I would screw the heatsink to two of the mounting rails, one on top, one on the bottom, and then have another mounting rail in front, and then that's where you mount the screw holes for the power amp too, etc. But yeah, I'm going to have a hard time mounting the heatsink to the rail because I don't know where it's going to come. I don't even know if this heatsink is going to fit. So I might have to change the idea yet again. Because I was going to use the similar heatsink that's on the back of my power supply, which is a 200mm long, 76mm high, and 30mm fin depth. Unfortunately, both boards will fit just snugly against the heatsink together like that. Unfortunately, where I've got to drill the holes for the centers of these transistors go in different places of the fins, and I can't make it line up without them overhanging a bit, and it looks ugly. So if this is not going to work, I might have to use, unfortunately, two separate heatsinks. And I'll probably use two of those 200mm long heatsinks that I just previously mentioned. So you'd have two heatsinks in the case taking up about 400mm of the width of the internal. I don't want to do that, but I'll cross that bridge when I come to it, because, well, I've actually got to assemble the boards and I've got to make them work and test them and all that. But now we'll move on to the schematic diagram for this, because there actually isn't one. Okay, I've been up since about 5:30 this morning, reverse engineering the circuit board. Well, in actual fact, I did actually search for that particular power amp online. I forgot to mention it's called the MX50 SE power amplifier. And there is already reversed engineered schematics on the internet, but they're hard to read, they're drawn really crappily, everything's all over the place, and it doesn't look nice and laid out. So what I did was I took a schematic that was already available on a audio forum, brought it up on the screen, and then I went through the circuit board and just verified that everything that was on that schematic was wired correctly and matched the circuit board, which it did. And then I just drew everything out by hand again, and then finally drew it out like it is now. But let's go through the operation of this circuit. Here's our input. We've got an input connection, an input ground on the same terminal, plus next to it is a large power ground. That's why there's two here. And that power ground would connect to the case to form the star earth point. So the actual power amp board was designed with star earthing in mind. We have a 100k input impedance resistor. Goes through a 4.7 microfarad high grade audio capacitor actually. Then in through a 1k stopping resistor. Now this stops it from picking up RF interference. along with this capacitor here, which is a 470 picofarad, that filters out any radio frequencies that might be present at the input of this base of this Q1 here, which forms the first half of the long tail pair or differential amplifier. Just above the differential long tail pair amplifier we have this transistor here. This is called a current source. This sources current through the long tail pair and keeps the current constant. And on each collector we have two transistors back to back, and this configuration is known as a current mirror. On the base of the second transistor here we've got our feedback resistor, negative feedback resistor 10K, and R12 here. This is what sets the gain. The gain in this configuration currently is 31. There's a 470 microfarad 16 volt capacitor here, which just sets the overall frequency response of the amplifier. And then there's a 100 nanofarad capacitor across it. What this does is adds a little bit more extra brightness or crispness to the sound, and so that's the current source for the long tail pair up there. Over here is the current source for the VBE multiplier, which is here, formed by Q9. Now Q9, Q10 and Q11 respectively are all mounted to that small heatsink I just pointed out in the kit there. And this transistor will change the biasing voltage to these two drivers respectively when the device gets hot. These drivers are then connected to the output stage, and both these transistor output stages are in C-clay compound pair. So it's very typical. The drivers are common emitter or emitter follower. Down here is the VAS or voltage amplifier stage, which comes off of the collector of Q1 respectively, with our 100 picofarad millicapacitor, and that just connects to the other end of the VBE multiplier. And over here we've got two diodes from the output going to, well, D2 is anode is mounted to the negative voltage line down here, as you can see, and this one up here, its cathode is mounted to the positive rail. What these are actually flyback diodes, which attempt to sink the current away from the output stage transistors, either in the positive or negative going cycle transient, if there is a short circuit to earth on the output. So it shunts the current away from the output devices back into the supply rails, and if there were inline fuses here, would exceed the current rating of the fuse and blow the fuse. That's the theory anyway. So there's no other short circuit protection on this amplifier bar these flyback diodes. There's no VI or voltage current limiter circuit in the driver stage here. One day I'll make a video about VI limiting and where it goes, what it looks like, and basically how it works. But any short circuit protection you put on an amplifier is not foolproof. If the short circuit's not detected in time, you can actually end up damaging the output stage or other transistors further in the circuit. Even putting a poly switch on the output like I did on that other amplifier, yeah, it works to limit the current flowing through the output stage, but it can still draw a tremendous amount of current through the output stage unnecessarily, even if that's there, and can still end up damaging the output stage if it's not detected in time. So, and also I've heard from various different sources that putting a poly switch, just like the old days of putting a fuse in line with the output, added distortion to the amplifier. Well, yes, this is true. It's measurable. Is it necessarily audible? No, not really, depending if you do it correctly. However, there's no short circuit protection on this amplifier, so I'm not sure exactly what I'm going to do to combat that. The other thing I didn't mention was I'm also planning on making this a 2.1 stereo amplifier. That is, having a separate sub output, but only using 2 power amps to power the speakers, and then having a audio output jack to go into an active sub, which I have on the floor over there. So I've ordered a any 5532, funnily enough, that uses that op-amp IC, low pass filter, and preamplifier for sub bass, which also features its own tone control or bass control on it, plus an overall volume, so you can actually adjust the amount of level going to the sub, which is nice. And that's the whole plan, is to build a 2.1 stereo of at least 50 watt per channel for the main front left and front right, and yeah, build my own amplifier. So that's the whole entire plan, and I hope you enjoyed this video. I know it was short and probably a little bit boring. It's going to be more boring for me to edit, but yeah, you get that. But that's going to be the upcoming set of videos. It's going to be called Project Amplifier. The first board to assemble, the first kit to assemble, would be the power amplifier. The next kit would probably be the preamp when it comes in. The next one would probably be the sub amp. I'm probably going to leave the power supply till last, until I've got all the parts in, including a power transformer, and then run some tests on that. And then the final video will be, well, hopefully assembled in the case and working. So anyway, I hope you're going to look forward to that, and I'm going to look forward to building it. It's probably going to take me about a couple of months, because I've got to buy a rack mount case, which will cost me $119. But yeah, we'll take it at one step at a time, and yeah. Thank you for watching. I'm the Astro 30, and if you enjoyed this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook and Twitter. The links are in the description as usual. Also, you can support me on PayPal by donating as little or as much as you want, because your donation allows me to buy stuff to play around with on the channel. And speaking of channels, check out this guy, 12 Volt Vids. He has some great content to do with electronics on his channel. Anyway, this is the Astro 30 saying see ya, have a great day.